Good day, Miss and everyone. My name is Cha Mui-Xuan with matrix number 205677, and my teammate is Ang Yifeng with matrix number 207277. The topic of our presentation today is the application of nanomaterials. Nanomaterial is one of the topics that we have learned during Sem 1 in material science. So before we start our presentation, I would like to ask all of you a question. Since all of us learn physics during secondary school, so what should we do when we want to convert nanometer to meter? Times by 10 to the power of negative 9, right? So from the term 10 to the power of negative 9, we can actually guess how small is the nanomaterial. So now let's have some introduction on nanomaterials. Nanomaterials can be defined as the materials possessing at minimum one external dimension, measuring 1 to 100 nanometer. They can occur naturally or can be created as the byproducts of combustion reaction. Nanomaterials can have different physical and chemical properties, and they can be produced purposefully through engineering to perform a specialized function. The contents of our presentation today will be mainly focused on the application of nanomaterials in medicine and also chemical engineering. In medicine, Bernard Marcus once said that nanotechnology in medicine is going to have a major impact on the survival of the human race. And this quote is proved by the statement which nanomaterials have many behaviors, such as chemical, electrical, optical, and mechanical behaviors. The nanomaterials that used in medicine are called as nanoparticles, and they have been developed for the treatment for cancer, allergy, diabetes, asthma, and so on. So in medicine, nanomaterials are widely used in imaging and diagnosis, or we can call them as bioimaging field. Nanomaterials are used for non-invasive and deep tissue penetration. An example of images produced by nanomaterials are infrared excitation, short visible emission lines, long fluorescence lifetime, and also superior photostability. The examples of imaging that require nanomaterials are optical imaging and magnetic resonance imaging. Next. So other than bioimaging field, nanomaterials are also used in disease therapy. This is due to the ability of nanomaterials to penetrate and accumulate at biological sites by enhanced permeability and retention effect. Nanomaterials can recognize and bind to target area via surface attaching specific lesions. So why development of nanomaterials is needed is to overcome some limitation found in the traditional therapeutic agents. The examples of disease therapy that require nanomaterials are photodynamic therapy and also photothermal therapy. So that's all from me. I'll pass the presentation to my teammate.
Hello everybody, I'm iPhone. So now I'll be bringing you to the world of chemical engineering. So how is nanotechnology used in chemical engineering? So nanomaterials can be used to prevent the micro-induced corrosion and increase the thermal transfer efficiency in industrial process. Basically, micro-induced corrosion normally happens in concrete sewer corrosion system. Since we all know that in the sewer system, the fluids flowing in the pipe are our feces, urine, and also other dirty liquids, and it consists of a lot of bacteria. So among the bacteria, there are two kinds of bacteria that is able to convert the hydrogen sulfide into sulfuric acid, which are sulfate reducing bacteria and also sulfide oxidizing bacteria. The sulfuric acid produced will slowly corrode the surface of a pipe. So there are some current approach to solve this problem, which is spray cleaning. But however, spray cleaning has two major disadvantages, which are uneven coating thickness and also it's difficult to adhere to pipe surface. So in the long run, the materials will start to flex and then they will fall off from the surface and the corrosion will start again. So by using the nanomaterials such as copper oxide nanoparticle solution with the help of electrokinesis technique, we can solve this problem as we know that nanomaterial is very tiny, so it can diffuse through the pore and diffuse into the concrete matrix, forming a strong protective layer. So this method will be better than the spray leaching methods. So next, since we all know that in industrial process, there are normally heat exchanger, as heat exchanger is very important to transfer the excess heat from one component to another. And normally in the heat exchanger, we normally use oil and water. But however, oil and water, they have low thermal conductivity, so that's why we need to put in some metal inside. So normally, in this case, the nanomaterial will be a better option compared to normal metal, since normal material can suspend longer in the fluid compared to normal metal. So example of nanofluid use is silver nanoparticles in water. So as you can see in the slide, by just adding 0.9 weightage percentage of silver nanoparticles, we can increase the thermal transmitter efficiency by 69.3%. So this performance is quite impressive. So in the future, nanomaterial will surely become a very important materials, and they will slowly replace our current material use in our daily life. They can be used to create another carbon nanotube wire, since we all know that carbon nanotube is very tiny. So who knows, maybe in future there will be a long wire made of mainly carbon nanotubes, and they can be implemented in the manufacture of transistor and used in optics and drug emissions. Nanomaterial can be used to create a longer lifespan industrial pipe, which will eventually save a lot of cost in industrial process. So to conclude, nanomaterials can be used in a wide variety of sectors, and it provides a lot of impact, especially in medicine and diagnosis. It also provides us a chance to have a better silver system management and increase the industrial efficiency. So that's our presentation. Thank you for listening.